right. Carbon monoxide poisoning. Carbon dioxide, oxygen, it's not the only things that we find in our bodies. It's not the only thing that we breathe in. Hopefully you never, but sometimes we breathe in carbon monoxide, which is colorless, odorless, tasteless, found in smoke from fire, cigarettes, exhaust fumes, yada, yada, yada. It will kill you. Do not breathe in carbon monoxide if you can help it, because carbon monoxide binds irreversibly with hemoglobin. Turns it into carboxyhemoglobin. Okay, it occupies the same binding spot that oxygen normally binds to, except it has a 200 to 230 times higher affinity, okay, for that binding compared to oxygen, which means it binds faster and it doesn't unbind. Okay, if it doesn't unbind, then you quickly fill up all of your oxygen binding sites, and now you are transporting carbon monoxide, which is useless to us compared to oxygen. Okay, the carbon monoxide also changes the shape of the hemoglobin molecule. Okay, any oxygen that is already currently bound to hemoglobins, the affinity increases, and so you are less likely to dump off the oxygen at the tissues. Okay, so this is really just bad all the way around. Symptoms include things like confusion, dizziness, nausea. If it gets really bad, this can kill you. Okay, you're basically starving your body of oxygen, just in a different way. Treatments are 100% oxygen or hyperbaric chamber. If you do not know what a hyperbaric chamber is, look it up. They're pretty interesting. Google iron lung in the olden days. Those are pretty cool looking. That's not what they still look like, but the iron lungs of the olden days, those are pretty cool. All right, carbon dioxide transport. Okay, so we know that carbon dioxide is a waste product that we make every time we use oxygen. We have already learned that quite a bit of that carbon dioxide is going to be dissolved in the blood plasma. A very small amount will be bound to hemoglobin molecules, and a lot of it gets turned into bicarbonate ions. Anywhere between 7 and 10% of your carbon dioxide is transported as dissolved carbon dioxide in the blood plasma itself. About 20% of your carbon dioxide is bound to the hemoglobins. This is going to occur when you are taking the carbon dioxide back to the lungs. Okay, the carbon dioxide actually binds to a different place compared to the oxygen, so there's really no competition there. When the carbon dioxide is bound, we call it carbaminohemoglobin, which is really hard to say. Okay, just do your best. Carbaminohemoglobin. The remaining 70% of your CO2, it's also in the plasma, but it has been converted into bicarbonate ions. Okay, this is a huge player in your pH homeostasis for your blood. The carbon dioxide quickly diffuses into your erythrocytes, your good old RBCs, where it comes into contact with an enzyme called carbonic anhydrase. Okay, and so we convert carbon dioxide into carbonic acid, which then gets converted into bicarbonate. These little arrows, okay, these ones going in both directions, means that this is a reversible reaction. So we can then take bicarbonate, we can turn it back into carbonic acid, and on your red blood cells, we can turn it back into carbon dioxide to breathe this out and get rid of it. Okay. Which is what this says as well. So the carbonic acid, okay, so the carbon dioxide gets turned into carbonic acid. Okay. You also end up with a hydrogen ion. Okay. These hydrogen ions can do lots of little things. Okay. Most of the bicarbonate stays in the blood plasma. Okay. The hydrogens will bind back to the hemoglobin. We can use these as buffers. Okay. If you remember buffers, hopefully you do, you remember that they are responsible for helping resist changes in pH. Okay. We don't want that. The bicarbonate ions themselves, with their little negative charge, they we don't want to build up too terribly much of anything. The negative charge here, we kind of do an exchange. You see this little exchange here, okay, where we exchange bicarbonate. We're gonna drop him off. We're gonna pick up chloride. Chloride ions. Okay. These chloride ions can also be useful to us. If you remember, H's and Cl's make hydrochloric acid. That's kind of useful to us. Okay. But it's also about balancing charges as well. Okay. So when it is time to get rid of that CO2, we have to do the reverse. We're going to take that bicarbonate back up into the red blood cells. We reconvert it to carbonic acid, which turns it back into carbon dioxide, which then we can exchange at the alveoli. Okay. So we breathe it in as oxygen, we turn it into carbon dioxide, we play with it, okay, get that bicarbonate, get all that carbonic acid, but when it's time to get rid of that CO2, it actually does have to become CO2 again. Okay, we keep talking about blood pH. I keep telling you it's important. I'm not fibbing to you. Okay, the carbonic acid bicarbonate buffer system is one of your primary buffer systems in your body. It's not the only one, but it is a big old deal. Okay, the buffer reaction is reversible, so we talked about being able to convert between carbonic acid and bicarbonate back and forth based on our needs. Okay. So depending on what else is going on in the body, depending on what else the blood pH is doing, will determine whether or not we are focusing more on making carbonic acid, or are we focusing more on making bicarbonate. So when your blood pH decreases, okay, when it becomes more acidic, okay, those hydrogen ions, which are basically acids, bind to the bicarbonate to go back to the hydrogens bind to the bicarbonate. We're basically making carbonic acid again. Okay. That carbonic acid will then go on to become carbon dioxide, and we'll get rid of it. Okay. So we were too acidic, so we turned the bicarbonate back into carbonic acid, which we're going to turn into carbon dioxide and just breathe it out. So that gets rid of the acid ultimately. Okay. When your pH goes up, when it becomes too basic, okay, we are instead going to go back the other way. We are going to take the carbonic acid, we are going to break it back down into bicarbonate and hydrogen ions. Okay. Those hydrogen ions again are acid. Okay, and so that brings your pH back down to where it needs to be. Okay. So here is just normal ventilation. Okay, our pH is our 735 to 745. Hyperventilation, hypoventilation. Okay, you can see how that affects your blood pH. Hyperventilation would increase your pH because you're blowing off too much CO2. Hypoventilation, you're gonna have too much CO2. It's gonna drop your pH. Okay, and we'll have to compensate in other ways. So this is one of the major players that regulates your blood pH. Okay, but we can have problems. We can hyperventilate. We can hypoventilate. We can have problems with our CO2 levels. Okay, when we suffer from respiratory acidosis or respiratory alkalosis, okay, if our lungs are our problem, okay, we're going to need somebody else to come in and fix our problem. So we're going to hear these terms when we talk about other body systems as well. All right, big picture. Okay, our big old summary slide. You've got your pulmonary ventilation, so literally taking air into and out of the lungs. Then we do pulmonary gas exchange. We put the oxygen into the red blood cells. We take up the carbon dioxide, put it back in the lungs to breathe it out. Then we have to do gas transport, so taking the blood to the tissues. And then we can finally do tissue gas exchange, where we can drop off the oxygen at the tissues and pick up the carbon dioxide from the tissues to eventually take it back to the lungs.